Today I am going to explain about liquid state. So in my last video I have already explained about gaseous state, right? Kinetic molecular theory, liquefaction of gas, and Boyle's law, Charles' law, Avogadro's law, Galus's law. All these laws and theories explains about gaseous state, right? Now I am going to explain about liquid state. This is part of states of matter, right? So in liquid state, generally intermolecular forces are very strong. Intermolecular forces are very strong in this liquid state, right? You have to observe. I am taking some liquid in a beaker. So there is all molecules are placed very closely, right? So that means intermolecular forces, the forces means there is attractions, repulsions, both are there, right? So these forces, intermolecular forces, are very high in liquids. Why? Because molecules are placed very closely each other. That means attractions and repulsions between them is very high. So in liquids, generally in gaseous states, intermolecular forces are very low. But in liquid state, intermolecular forces are very high. Molecules in liquid very close, that there is very little empty space between them. Molecule to molecule, the space between them is very low. That means very closely they are placed. That's why intermolecular forces are very high. And liquids, generally in liquid states, liquids have definite volume, right? Definite volumes. Generally in gaseous state, in gases does not contain definite volumes. But in liquid state, liquids contain definite volumes, right? However, molecules of liquid can move fast one another freely. Generally, molecules present in the liquid state are moving very fast, right? Generally, that's why always the liquids are flowing like manner, right? Not steadily constant, always flowing manner. That means the molecules present in the liquid are very free to move. So then liquid state, the physical properties of liquid state, the physical properties of liquid state is vapor pressure. Next one is surface tension. And the third one is viscosity. Right? Viscosity. So these are the physical properties of liquid state. Vapor pressure, surface tension, viscosity. Let us discuss about these three properties. Vapor pressure, right? So you have to remember 2 points. In liquid state, intermolecular forces are very strong. Why? Because molecules are closely placed each other. That's why intermolecular forces between them is very high, and liquids contain definite volumes, whereas coming to the gases does not contain definite volumes, and intermolecular forces between them in gases are very low, right? So let us discuss about vapor pressure. So here I am explaining one example. So let us take one beaker filled with liquid, and This beaker is, I am closing this beaker with a lid, closed lid, right? So beaker is filled with liquid with a closed lid. This is closed, right? When we apply heat to this beaker, what happened here? You have to think once. When we apply heat to this beaker, what happened? The molecules present in the liquid slowly goes to the surface of the liquid, and slowly these molecules goes to the walls of container. This is vaporization, right? That means molecules present in the liquid goes to the vapor state. We are seeing in our homes also. So when we heat the water in any vessels, and that vessel is closed, so when we apply high temperature to it, what happened? So the molecules present in the water goes to the walls of the container, walls of the vessel, that means walls of the vessel, and it's boiling, right? That means there is vaporization happens. Right? When we apply high temperature to it, what happens? The molecules present in the liquid goes to the vapor state, right? That means vaporization happens. In initial stage, what happened? Rate of vaporization is high, and slowly over a period of time, what happened? This vapor state again converts to the liquid state. That means condensation happened. In first stage, vaporization happened. In second stage, condensation happened. Condensation means vapor state to liquid state. The process of converting vapor state to liquid state, right? So, at initial state, rate of vaporization is very high. And rate of condensation is very low, right? But at intermediate state, what happened? Rate of evaporation is low. Rate of evaporation is very low, and rate of condensation is high. At intermediate state. But equilibrium state. That means at this stage, rate of evaporation is equal to rate of condensation. At equilibrium state. So, at equilibrium state, rate of evaporation is equal to rate of condensation, means at this state there is liquid phase, there is vapor phase also. Vapor phase is placed at the surface of the liquid phase. That means rate of evaporation is equal to rate of condensation at equilibrium state. That means the molecules present in the vapor phase, right? The pressure exerted by the vapor molecules and equilibrium on liquid is called vapor pressure. Is called vapor pressure, right? So that means the molecules present in the vapor phase the molecules present in the vapor phase it shows pressure on the liquid phase molecules. The pressure is like this way, right? That means the pressure exerted by molecules present in the vapor phase and equilibrium on liquid phase is called vapor pressure. Is called vapor pressure, right? This is vapor pressure. So at equilibrium state, rate of evaporation is equal to rate of condensation. That means in this state vapor pressure is equal and liquid phase is also vapor phase is equal and liquid phase is also equal. At this stage the molecules present in the vapor phase shows some pressure on molecules present in the liquid phase, right? So the pressure exerted by vapor molecules and equilibrium on liquid is vapor pressure, right? This is vapor pressure. Understand clearly? So at initial state what happened? Rate of evaporation is high, rate of condensation is low. At intermediate state rate of evaporation is low and rate of condensation is high. So evaporation means liquid state to vapor state, right? Condensation means vapor state to liquid state. You have to observe clearly. Vaporization means liquid state to vapor, condensation means vapor to liquid. So at starting state evaporation happens, that means liquid state slowly converts into the vapor, but slowly again condensation also happened here, that means vapor to liquid. But at equilibrium rate of evaporation is equal to rate of condensation, that means evaporation is equal to condensation. At this stage vapor phase is placed at surface of liquid phase. So the pressure exerted by vapor molecules and equilibrium on liquid is vapor pressure. This is vapor pressure, right? So generally vapor pressure is depends on two factors, right? So what is two factors? Nature of liquid and effect of temperature. These two factors affects the vapor pressure. That means vapor pressure, this pressure is depends on nature of the liquid and effect of temperature. Right? So in this vapor pressure we will study about boiling temperature also. So what is boiling temperature? The condition of free evaporation throughout the liquid is boiling. Free evaporation throughout the liquid, that means the all molecules present in liquids goes to the vapor state. Free vaporization throughout the liquid. The molecules present in the liquid states goes to the vapor state. Right? So in this process is called boiling, right? Generally 1 atm pressure boiling temperature is called as normal boiling point. 1 atm pressure, boiling temperature is called normal boiling point. At 1 atm atmospheric pressure, boiling temperature is normal boiling point, right? If the pressure is 1 bar, then boiling point is called as standard boiling point. If the pressure is 1 atm, boiling temperature normal boiling point. If the pressure is 1 bar, the boiling temperature is called standard boiling point. Because 1 bar pressure is slightly less than 1 atm, right? Slightly less than. That means 1 bar is slightly less than 1 atm. That means standard boiling point is lower and normal boiling point is higher. Normal boiling point is higher than standard boiling point. Right? So, and this boiling does not occur when liquid is heated in a closed vessel. Liquid in closed vessel. So boiling occurs only the vessel is when opened, but does not occur in the liquid in closed vessel. Right? So on heating continuously, vapor pressure is increases at the first. So liquid and vapor phase, because the liquid is more dense than the vapor, obviously, right? So liquid is more dense, that means more weight. Then vapor phase, right? Whereas coming to the liquid phase, more dense, whereas coming to the vapor phase, less dense. So when density of liquid and vapor becomes same, the clear boundary between the liquid and vapors disappears. This temperature is called as critical temperature, TC, right? So when density of liquid and vapor becomes same, generally the density of liquid is more generally. That means in liquid state density is very high, in vapor state density is very low, right? So but the density of liquid and vapors becomes the same. The clear boundary between the liquid and vapors disappears. This temperature is called critical temperature, TC, right? At this stage, what happened? Clear boundary between liquid phase and vapor phase disappears, right? So at this temperature is called as critical temperature. All this about vapor pressure. So the pressure exerted by vapor molecules and equilibrium on liquid is vapor pressure. That means at equilibrium state, what happened? At equilibrium state, rate of evaporation is equal to rate of condensation. At this state, the molecules present in the vapor phase shows some pressure on the molecules present in the liquid phase. right? The pressure exerted by vapor molecules and equilibrium on liquid is called vapor pressure. So the two factors affects the vapor pressure. One is nature of liquid and another one is liquid effect of temperature. That means it depends on two factors, nature of liquid, effect of temperature, right? And the boiling is the condition of free evaporation throughout liquid. Free vaporization throughout liquid. But the boiling occurs only when the vessel is open. The boiling does not occur in liquids in a closed vessel, right? So generally liquids have more dense, more weight than the vapor. In liquid phase have more dense and in vapor phase there is less dense. Right? So at critical temperature, clear boundary between the liquid phase and the vapor phase disappears. At this temperature is called as critical temperature. This is all about vapor pressure. So vapor pressure is one of the physical property of liquid state. Thank you.